Alright, so in this video, I'm just going to go over questions 5 to 8 in homework 2.1. I'm not going to go over questions 1 to 4 because I feel like you guys can do that those yourself. But I will do the math involved in 5 to 8. So again, if you haven't watched the class videos 8G to H something, I'm just going to go over the trig again very briefly, right? So if you look at this tension in this rope, right? So the tension in this rope can be split along the y-axis, right? Along the y-axis and along the x-axis. So we can split this tension along the x and the y, right? Now, when you're doing trigonometry, we know that this ty right here is adjacent to my angle. And again, the rule I kind of talked about in the other class video is that, well, you can think of sine as opposite and you can think of cosine as adjacent. And that's something you can just always do. And when you see that this Ty here, this vertical tension force, right? This vertical tension is adjacent to this angle, well, we can say that this is cosine. I'm gonna write my hypotenuse, and you're always gonna begin with your hypotenuse T. And then because again it's adjacent, it's T cosine theta. Right? And that's really just something you can do. Right? It's something you can do here. You start with your hypotenuse T, cosine, because it is adjacent to this angle, and your angle is 30. Right? So you can see that, well, that my vertical tension from this rope here is T cosine theta. Right? So that T cosine theta over there from this rope. And this other rope, the second rope, also exerts a tension of T cosine theta in the vertical direction. So this problem reads that this object is at rest, which means that my total net force acting in the y direction is 0. And now we're going to list all our forces acting in the y direction. And so vertically I have T cosine theta, that's the first one. Another T cosine theta, which is the second one. And we also have a downward force of 410 newtons. And we also have the weight, right? So the individual weight of the ornament itself, of the object itself. My weight, while the problem does give us the force for 10 newtons, the weight is something we have to calculate ourselves, right? The weight is our force due to gravity. And our force due to gravity is equal to mg, right? So it's mass times gravity. So we're given our mass, and then our acceleration due to gravity is 9.8. Right, so our weight here is 6 times 9.8, so it's 59 point something, 59.8. So let me just double check. Just double check real quick. $58.8 actually. $58.8. Oh yeah, that makes sense. So this is 58.8 newtons. Right, so now all we need to do is kind of just plug in everything, right? So again, the question wants you to know, well, what's the magnitude of tension T? So T cosine theta minus T cosine theta. My force is 410 minus 410. My weight is 58.8. All right. I'm gonna start replacing this, right? So my net force there is 0. My tension is what we want to solve for. My cosine, well, should be plus. This should be plus here. Cosine theta is 30, right? So cosine 30 plus T cosine 30. This gives us minus 468.8. We can further simplify this by saying, well, T cosine 30 plus T cosine 30 gives us 2T cosine 30 minus this, right? And then we're going to add this on both sides, right? So we do this, that, do that. T2, that. I'm just gonna move this over here, right? So 468.8 to T2 cosine 30 divide 2 cosine 30 on both sides. And then we should get, if you do the math, we should get 271 newtons. Right, and so this is my tension. This is my tension. We successfully solved for tension here. All right. So let's do number 6. Let's do number 6. Say 400 kg box, right? That's your mass. Lifted vertically upward, constant velocity. So you know the object is in equilibrium. So it's being lifted upward. So we can say, well, my vertical net force is 0. You can put at 40 degrees on either side in vertical direction, and it was the tension. So you draw a diagram of this problem. You should see, well, we have something, a box being lifted vertically upward. You're being pulled at 40 degrees to your vertical. Right, so this is 40 degrees. This is also 40 degrees right there. And there's also a downward force due to gravity. Right? So you have tension in both of these ropes, and you have a downward gravitational force. So again, like we did last problem here, our vertical vector for these tensions, right, it's adjacent here. Our vertical vector is adjacent to my angle. So I'm going to say that, well, that's t cosine 40, and the same thing for the other one, right? So these are my vertical vectors for my tension, my rope. So if we do our net force here, well, it's equal to t cosine 40, right? That's one vertical force, plus t cosine 40, that's another vertical force, minus my force due to gravity. If we further simplify this, t cosine 40 plus t cosine 40, that's 2t cosine 40. My force due to gravity is mg, my mass is 400, g is 9.8. And we do get around 3,920. So that really would be my force due to gravity. So we're just gonna replace that variable with 3,920 newtons. I'm gonna get rid of that newtons there, right? So we don't really need the newtons. So it's 3,920. So I'm gonna further simplify this, right? 0, 2t cosine 40 minus 3,920. I'm gonna add 3,920 to both sides. 3,920 both sides. 2t cosine 40. Divide 2 and cosine 40 there. 2 cosine 40. And then when you do your math, you should get 2,560 newtons. And this would be your tension, right? So now we successfully solve for tension there. Well, I'm going to do question 7 last. Question 7 is really the most tedious problem. So I'm going to start with question 8. So let's do question 8 here. My app is bugging out again. So I'm going to wait for the app to load because it is pissing me off. So we have 8. The figure shows a block of mass m hanging at rest. It's in equilibrium. The light wire fastened to the wall is horizontal and has a tension of 38 newtons. So the tension of this rope right here is 38 newtons. So to the right. And the wire fastened to the ceiling is also very light, has a tension of 59 newtons, right? So we can say, well, the tension of this rope is 59 newtons there. It makes an angle with the ceiling. And then the question wants you to find out, well, what is your angle? What is your angle, right? So let's actually look at our, since we don't know my force due to gravity, we don't know the mass of this mass, we probably can't really solve for uh, our y direction, right? We can't really use our y direction here. We definitely do not know our mass, and we definitely don't know my force due to gravity. So let's try using my forces in the x direction. So we know our object is in equilibrium, it's at rest. So we can say that, well, my net force here, my sigma fx is 0. Well, what are my forces acting in the x direction, right? What are my forces acting in the x direction itself? Well, we know we have a horizontal force of 38 newtons to the right, so I'm gonna put 38 there. But what's my horizontal vector in the opposite direction? Because we have a tension of this rope at an angle. We have tension of rope at an angle, and that's angle. But what we can do here is that we know that both of these angles are the same. And well, in reference to this angle, what is this? I'm gonna call this tension X, right? What is tension X in reference to this angle? Well, this tension right here is adjacent to this angle. And we're gonna begin with our hypotenuse, right? It's always our hypotenuse. And because it's adjacent, it's hypotenuse cosine theta. Right? So now then I can say, well, it's minus 59 cosine theta. Because again, this is in the opposite direction. It's in the opposite direction. So again, so you have 0 is equal to 38 minus 59 cosine theta. I'm gonna add 59 cosine theta to both sides. Well, I took one extra step than necessary, but whatever. I'm gonna add 59 cosine to both sides. It cancels out, and now we have 38. Divide by 59 on both sides. All right, so now we have cosine theta is equal to 38 divided by 59. To get rid of this cosine, right, we have to do cosine -1, cancels out. And then we do cosine -1 on the other side. And then our angle, we should get, well, I don't really know. Actually, we should get 50 degrees? I think we should. Let me just do this. 38 divided by 59. Yeah, you should get 50. So you get somewhere around 49.9, and then you're just going to round it to 50. So the answer here is 50 degrees. You get 49.9, and then you round it to 50. All right. So let's do question 7 now. Let's do question 7. It's bugging out. Something's bugging out. Great. Great, great, great. Great, great, great. Perfect. Ah. All right, fine. So I get this. Question 7. So a 10 kg picture held in place by 2 wires. Right, so we can say that you have a picture. Right, so I'm gonna draw the picture as a dot. So there's a force due to gravity acting on the picture itself. First one hangs at 50 degrees to the left of the vertical. Right, so this is 50 degrees. 50 degrees. And second one to 45 degrees to the right of the vertical. Right, 45 degrees to the right. So then the question says, what is the tension in the first wire? I'm gonna call the first wire T1. I'm gonna call the second wire T2. So again, the object is in equilibrium. What we can do is we can kind of just say that, well, my net force in the x direction is 0, And we can say that, well, my net force in the y direction is 0 as well. And the total sum of my forces in the x direction here, right? If we take a look at our x direction, we have our tension in the x direction. We can split it off. And this tension, if you kind of think about it, well, my tension I can do like that too. I can make a triangle like that above here as well. And it'll pretty much be my horizontal vector. So we can do this. So we can say that this is also T1x and this is also T2x. So we can say those are my horizontal vectors. And what is this horizontal vector equal to, right? So this horizontal vector T1x is what? It's opposite of my angle, right? So it's opposite of my angle, which means that that's sine. And we always begin with, again, the hypotenuse. So that is T1 sine 50. And the other side is T2 sine 45, right? We always begin with hypotenuse. And then we follow up with either sine or cosine. So my horizontal vectors here are T2 sine 45 minus T1 sine 50. Again, we're subtracting this because, again, this is my horizontal vector acting in the opposite direction. And so that's my that's what it should be. That's what it should look like for my net force in the x direction. I'm just going to do up to here. T2 sine 45 minus a T1 sine 50. And if we go to the other side here, right, if we go to the other side, my Fy here is, again, so we look at our vertical vector. And my vertical vector is adjacent to my angle. Right, my vertical vectors here are adjacent to my angle. So it's cosine. And again, I'm going to begin with my hypotenuse. I'm going to say T2 cosine of 45 degrees plus T2 cosine 50, right? Because those are my two vertical vectors. Actually, this is one, T1 cosine 50, because that's the tension of the first row. And I'm going to do minus my force due to gravity. And my force due to gravity is mass times g, so it's going to be 10 times 9.8, right? Which means that it's going to be minus 98. So now what, right? So now what do we do? Now what do we do? Again, keep in mind that this T1. So now we're at a crossroads, right? The question wants to know, well, what is the tension in the first wire? What is T1? What is T1 equal to? Well, we have to set up an inequality, right? We have to first of all get rid of T2. We have two unknown variables, but can we get T2 in terms of T1? Is there some way we can do that? Well, we can, right? I can solve for T2 in terms of T1. I'm going to do it. You can either do it with your x, net x, or net y. I want to rewrite this first. Rewrite this. I'm gonna rearrange T2 in terms of T1 using the net x side. So I'm gonna add this to both sides, right? I'm gonna add T1 sine 50 to both sides. And then I got T1 sine 50 is equal to T2 sine 45. And then I'm going to divide sine 45 on both sides, right? Because I want to isolate T2. And now I have T2 and then T1 sine 50 divided by sine 45. Sine 50 divided by sine 45. Divided by sine 45. And we get 1.083. I'm just going around to 1.08. 1.08 T1. So now that we successfully figured out what T2 is, we can actually just plug it into our net y equation, right? So now we have 0, again, I want to bring this down, is equal to T2. Again, T2 is 1.08 T1 cosine 45 plus T1 cosine 50 minus 98. Let's kind of simplify everything here first, right? Let's kind of simplify everything. 1.08 T1 cosine 45. So I'm gonna do cosine 45 times 1.08. And then I'm gonna get 0.76 T1. I'm rounding this, by the way. Plus cosine 50 T1. I'm gonna do cosine 50. All right, we'll do cosine 50 T1. So this is gonna be 0.64 T1, right? Minus 98, minus 98. And now we just add up the T1s because they are like terms. This is 1.4 T1 minus 98. I'm gonna add 98 both sides. Alright, so 98 is equal to 1.4 T1. And we'll divide by 1.4. And then 98 divided by 1.4 gets you somewhere around 70. Right, so it gets you somewhere around 70 newtons. And then, well, the answer here would be A. All right, so that's that. That's the video. That's the video.